I hope my slides are visible to each and every one of you. I'm going to start with the introduction part. So I had these two questions about what is blockchain and Web3, and where does the security part come about it. Blockchain, yes, is a new technology that has erupted, but blockchain is a decentralized distributed ledger that stores transactions in blocks linked together using cryptographic hashes. A ledger from, let's borrow the knowledge from the business people. They create ledgers and all the transactions of everything that they have bought, they are recorded there. So blockchain is just like that ledger and decentralized. It's not owned by anyone, but it's not owned by any government or anyone, but only you are the one who is responsible for its. You are responsible to protect your ledger. And Web3, this is a decentralized version of the internet where the blockchain technology enables users to control their assets and identities. Now, blockchain security. Here in blockchain security, we protect the blockchain networks, smart contracts, the digital assets, and cryptographic systems from the attacks. So blockchain security we measured in smart contracts, protect smart contracts, the network of blockchain, and the digital assets in there, and the cryptographic systems. And Web3 security, it protects the decentralized ecosystem. Inside here Web3 we have the blockchain infrastructure, in which here Web3 it protects all the ecosystems, and in this ecosystem the blockchain is still in it. The smart contract is still in it. Since in Web3 we have the decentralized apps, some things like fintechs here. So in the architecture of the blockchain technology, we have blocks. So each block holds a cryptographic hash, or which let's imagine we have two blocks which are horizontal. Yeah, they are following each other. So the first block and the second block has the first hash of the first block. So if somebody tries to attack the first block, he needs to get the hash which is there. And to get this cryptographic hash, it's very difficult. In which the second block, if a new block is being created, it carries on the cryptographic hash which was on the first block. So for you to break that hash, it's very difficult. So that's immutability. So if you want to change any block and you don't get the correct cryptographic hash, the whole chain breaks. So we go to decentralization. Decentralization, this is where data is spread across thousands of nodes. No single point of failure. Attacking one node changes nothing. So what am I saying? In blockchain, you have seen that a node is something like, let's say, a computer. There are various nodes each and everywhere. Computers, let's say I have a computer where I am, you have a computer where you are. So the data which is in my computer is the data which is in the location you are. So even if you want to change the data in your computer, the same data you are changing there, I have the data in my computer here. So it's very difficult to change anything. And cryptography. Cryptography, we know here we have the public keys, the private keys. The private key is the one that you own, and the public key is the one that is very known to each and everyone there out. It's a public. So you yourself, you're the one to control your ownership by protecting your private key. See, if you give out your private key, this means that your wallet is it's in a risky point. It is in a risky point. Yeah, that's how I can rephrase it. And consensus. All nodes must agree on valid transactions. So those bad actors or attackers, they need to control the majority to do the cause here, to do the cause harm. What shall I say in consensus? All nodes, all the computers. So my computer in wherever I'm located, and the computer in wherever you're located, they have to agree, because those blocks have to agree to the same transaction that it's happening, so that you can transact your cash. Yeah. So let's dig into the vulnerabilities in the smart contracts. We have the reentrancy attack, access control, 51% attack, and integer overflow. I'm going to shift to another slide because I had no, I didn't have enough time to create the slides to be all in one place. Okay. Oh, the first attack is the reentrancy attack. Here in the reentrancy attack, in a scenario, there's a target contract and there's an attacker contract. So a target contract, it sends some ether to an external attacker contract before decreasing its recorded balance. The attacker falls back or receives function executes immediately upon receiving the funds. The fallback function calls back into the target's withdraw function again before. It explains how the attack mechanism works. So this is where an attacker calls a function. Before that function is executed, all the attacker is able to drain some ether from the target's contract. This comes about here we have the contract recursively releases funds until gas runs out or contract's balance is zero. Let's check the mitigations. Yeah. Always, this is how you can prevent the reentrancy attack in the smart contracts you are building. Always perform a safety check first and update internal storage into the balance should be equals to zero. And then perform external calls or either transfers strictly last. Another one is reentrancy guard look. You should use some modifiers like the open zip line. This is an reentrant which sets an internal status lock when a function starts blocking reentrancy calls. Into the next attack. to the next attack, we have the integer overflow. Integer overflow, it's like some mathematics there. This, let me bring it into an understandable way. Let me give you a scenario. There was a smart contract. There was let's say, you all are very familiar with some steps we were given, and it was you had to determine what the attack was, and I came about it was the integer overflow. Here, there was a certain hardware, which the hardware was very old, an older version of it. So in integer flow, there's a certain number, there's a certain maximum number in which if we exploit it in a way that it surpasses that number, we can drain the cache from that hardware or that software. So here it shows us that the fixed with integers wrap back to 0 when exceeded maximum allowed storage capacity. Underflow exploits if we subtract 1 from the uint to 56 wraps to giving huge balances. Token minting flows, attackers, they bypass the transfer restrictions or mint trillions of uncollateralized tokens. And Solidity 0.8, this is the version of the new Solidity, built-in automatic reversion on arithmetic overflow. How to prevent this? So we have these versions of Solidity. We have the 0.80, we have the 0.6 something. So you have to, when you are building your smart contract, you should only make sure that the version of your Solidity there is 0.80, and the safe math library for legacy code bases, primitive operators with safe math, sub, and mult. Then we have the explicit unchecked blocks. Only wrap loops in unchecked blocks when gases optimization is essential. On to the next attack. We have the 51% attack. A 51% attack occurs when a single entity or colluding pool controls over 50% of blockchain mining hash rate or total staked voting power. Attackers can record transactions, execute double spend scams, censor competing blocks, and freeze transactions confirmation across the network. So the 51% is when we have the control of over 50% of the hash rate in the network. So an attacker can try to manipulate the network in one way or another to make some transactions and even to execute some double spending. The access control vulnerabilities. The access control vulnerabilities. This vulnerability comes as when you miss some functions. I don't think here they're visible. Oh, there's some functions which you miss to put. Let's say like the logical bags flow. There's some functions which you can miss to put in place in your smart contract, which makes an attacker to make he himself the owner of that smart contract and ends up withdrawing the cash from your contract. Yeah, and yeah, those are the 4 common vulnerabilities which I had to talk to you about the smart contract. When we go to Web3 security, which, I did not do the, forgive me, I did not do the slides for Web3 security, but the Web3 security comes from the word web. We know it's a web. So there's some XSS, cross-sighting, scripting, there's some phishing there, and there's some logical bugs which the developers can do. So, and the smart contract bugs, which we have already talked. Since we said the Web3, it contains all the ecosystem in which the smart contracts are still in it in the Web3. So the Web3 security, we must focus on the also protecting the front end. Yeah, I don't know if I went fast, but that's all the presentation that I had for today. If there are any questions.